go through the intro to correlation activity that you were given for homework. This also is good for you to double check if you need extra help. There's another video that shows you how to use your calculator. So the first thing that I do is enter the data into two different lists, double checking to make sure that your numbers are right. It's worth doing a just quick check there, because if you do the whole thing with wrong numbers, then it messes everything up. Okay, so I did the one variable stats for each list, and really you're doing this because you want to double check with somebody else, but also that if you graph the line of regression, it's going to go through that point 15, 29, and 15 is the age because that's what we're putting on the x-axis, and 29 is the distance. So it's going to go through that point, and so we'll check on that later. So when we go to graph, when we go to stat plot, turn on my stat plots, and I already have it on the scatter plot. Your x values are independent, your y values are dependent. And I'm just make those dots, hit enter and graph, and then you realize nothing shows up, so you need to go to zoom, stat, and now I can't see the axes. I can see all my points, but I can't see the axes. So again, changing your window is pretty critical to understanding how to use your calculator. So let's look at the window. I want to make sure I'm not starting at the smallest value. I want to start at 0 and on both axes. And I know that makes the graph a little stretched out, but when you go to sketch this, you can get an idea from what's on your window. So my x min is 0 and my x max is 21, and I might even check and see if 20 cuts off a point, but the biggest x value is 20. So even if you go to 20, and so you mark that on your scale, notice I have, and then I can figure out the points in between later on. And I'm going to look at my y values. My y min is 0 and my y max is 55.95, and so I might just change that to 60 so that I can have a better splitting up of all these values. So if it's actually asking you to make a scatter plot, at this point you need to make a scale and then plot the points. There's not very many points. Couple things to think about: make sure you label age here, distance here, and then you're going to go about plotting all those points. Just make this video not too long. I'm going to let you plot the points, but if you know this is 20, then you can work your way back from here. So here's 10. So it's a little bit of a bent scale here, because we have, so right here is 30. So if you just get a good approximation of where things are at, so 15 is in here, 5 is in here, and you could plot. Let's go back and get the line of regression now. So I'm going to exit out of here, stat, calculate linear regression. Make sure that you have the X list in the first list, no frequency list because we don't have frequencies. You can store the linear regression equation in the Y variables. I'm going to store it under Y1. And so it gives me the line of regression. I'm going to write that down. Y equals 3.29x plus negative 20. So that means my y-intercept is down here somewhere, and my slope is positive, so you know it's coming this way. If I go to graph, I either have to put that in my calculator, or I already pasted it if you didn't paste it. So I also want to make a note of r equals 0.917, and r squared is 0.841. Okay, so now when I look at the graph, it's a pretty strong correlation because the data values are right around here. And again, I'm going to show you, if you push trace, it's going to hop around the different points, and then if you push up arrow, it goes to the line and it follows the line, and we should be able to see 1529 or pretty close is right there. If you want to do calculate a value, you could enter 15 for X. It should give you 29. That's a way to check the X bar, Y bar. So the average X and the average Y, your line needs to go through that. Okay? And so you can answer some of these questions. Measuring the relationship is finding R. So then to be able to answer the question after that, what happens, do you think the athlete can throw is related to the person's age? Yes. There's a strong positive linear correlation. And that's what you say. Those are the words you say. You don't have to give a reason. What happens to the distance thrown as the age of the athlete increases? And you'd say as the age increases, the distance increases. If you're wondering, like, how do I decide how strong it is, you'll get a handout that shows a scale, but here's some different examples of the strength. And so you can see strong positive, the line, the points are bunched up more around the line. Okay, and so there's two different directions. This is positive, think about positive slope, and this is negative. And there's no difference between positive and negative correlation except for the direction.